Session 5, Add Local Size. This session focuses on techniques for refining mesh quality in Fluent Meshing by adjusting local size parameters. Key topics covered include face size and body size. Learn how to define and adjust the sizes for specific faces and bodies to enhance precision in critical areas. Body of influence, BOI, and face of influence, SOI. Understand how BOIs and SOIs can be utilized to control mesh density around crucial geometric features. Curvature proximity. Explore methods for refining meshes in regions with high curvature, ensuring better representation of geometry. Create local refinement regimes. Develop strategies to implement local refinement, which helps in balancing computational cost with the accuracy of the results. This session is designed to equip you with the skills necessary to optimize your mesh for complex simulations while maintaining computational efficiency.
Before I discuss how to create local sizes for face sizing and body sizing, I would like to show the geometry created in the design modeler. You can see that there is a cube united with a half cylinder, and there are named selections: inlet, outlet, and wall. The outlet is indicated, and the surrounding area is designated as a wall. We have named the body as flow. In Fluent Meshing, the geometry is imported into the software. Before I demonstrate how to create or add a local size, I want to create a mesh without any local size. So I navigated to the Add Local Size option, and when prompted with, "Would you like to add a local sizing?" I answered no. I want to generate the mesh. However, before proceeding with other sections in this session, I must mention that you should go to the Describe Geometry step and choose the option that indicates the geometry consists of only fluid regions with no voids. After that, proceed to generate the volume mesh. By clicking on Generate Volume Mesh. And when the software asks a question, you have to click Yes. After this, the software will begin generating the mesh. You can see that the software generates a mesh where the cells are almost equal to each other. If you want to see the number of cells generated, go to the Report tab, click on Mesh Size, and then click Update. You will see that approximately 12,000 cells have been created. Now it's time to create a mesh with added local sizes. When prompted with, "Would you like to add local sizing?" we answered yes. After that, in the Size Control type, choose Face Sizing. We want to use smaller faces in important parts of our domain, specifically the inlet and outlet. Using a target mesh size of 0.002 meter. We do not change the growth rate. After that, click Add to Local Size. Similarly to the previous mesh creation, navigate to Describe Geometry and choose the option indicating the geometry consists of only fluid regions with no voids. Then proceed to generate the volume mesh. When the software asks a question, ensure you click Yes to continue. When the mesh generation is completed, you can see that near the important parts of the domain, such as the inlet and outlet, the cells are smaller than in other parts. If you want to see the number of cells created, click on Report, then Mesh Size, and click Update. You will see that the number of cells created in this mesh is approximately 3 million. Here, You can see the difference between when we use face sizing and when we don't use face sizing for generating the mesh. Before showing how to create a body size in Fluent Meshing, I want to demonstrate the geometry I created in the design modeler. We have the previous geometry, and we added a cylinder in the middle of it. If we hide the cylinder, you can see that it is subtracted from the previous geometry. I show all the bodies again. You can see the boundary condition names, flow, followed by cylinder, and at the inlet condition, which is at the beginning of the cylinder. After that, you can see the wall and outlet boundary conditions. Finally, you can see an interface. And I need to add that we use form new part to ensure a conformal mesh is created. Before generating a body size mesh, I want to create a mesh without body sizing for this geometry. First, go to the Add Local Sizing section, and when prompted with the question, would you like to add local sizing? Answer no. After that, go to Describe Geometry and specify that the geometry consists of both fluid and solid regions, or voids. Then, proceed to generate the volume mesh by clicking on Generate Volume Mesh and answer Yes when prompted. The software will then start to generate the mesh. Now you can see the software generating the mesh, and most of the cells are approximately equal in size. To check the number of cells generated, go to the Report tab, then select Mesh Size and click Update. You will see that the number of cells created is approximately 15,000. Now it's time to use body sizing to generate the mesh. Start by going to the Add Local Sizing section. When prompted with the question, would you like to add local sizing? Answer Yes. In the Size Control Type options, select Body Sizing, and for the target mesh size, use 0.024 meters. Choose the cylinder in this selection box, and then apply the local sizing. After that, go to Describe Geometry and select that the geometry consists of only a fluid region with no voids. Then, click on Generate Volume Mesh, Part. Then click on Generate Volume Mesh, and when the software asks question, answer Yes. The software will then start to generate the mesh. The software is generating the mesh, and you can see that in the cylinder part, the cells are smaller than in other parts. If you want to see the number of cells generated, go to the Report tab, select Mesh Size, and click Update. You will see that approximately 6 million cells have been generated. Here you can see the difference between when we use body sizing and when we don't use body sizing for generating the mesh. Before discussing how to use Body of Influence, BOI, I want to show the geometry created in the design modeler. We have a body with a cylinder in the middle, but the cylinder has not been subtracted from the body. I show all the bodies again. You can see the boundary conditions, inlet, wall, and outlet. This setup also includes a body of influence. In Fluent Meshing, once the geometry is imported, you can use the Insert Clipping Planes to view the interior of the geometry. In the Add Local Sizing section, change the option from No to Yes. Select Body of Influence as the size control type. and choose the designated body of influence in this box. Once you click on Add Local Sizing, you might notice that the cylinder disappears. After that, in the Describe Geometry section, specify that the geometry consists of only fluid regions with no voids. Finally, in the Volume Mesh section, click on Generate Volume Mesh, and the software will begin generating the mesh. The mesh has been generated in the software, and you can notice that in the cylinder part, which is the body of influence, the cells are smaller. We use this method to create a finer mesh in specific areas of the domain that are important, which helps improve the accuracy of the simulation in those regions. For the face of influence, we created this geometry, which includes a body and a surface. If I hide the surface, you can see that we have not subtracted the surface from the body. I'll show the surface again, and now I'd like to display the boundary conditions. This is the inlet, here is the wall, and this is the outlet. Finally, this is the surface of influence. Insert the geometry into Fluent Meshing. By clicking on Insert Clipping Plane, you can view the inside of the geometry. Change the option from No to Yes in the Add Local Sizing section and select Face of Influence as the size control type. Enter a target mesh size of 0.01 and choose the surface you created in the relevant box. Then, click on Add Local Sizing. In the Describe Geometry section, select that the geometry consists of fluid regions with only voids. Finally, in the Volume Mesh section, click on Generate Volume Mesh, and the software will begin generating the mesh. Now that the software has generated the mesh, you can see that if you zoom into the body around the surface, the software has generated smaller cells compared to other parts of the domain. This finer mesh in the vicinity of the surface helps improve the accuracy of simulations in that specific area. Here, we can compare the body of influence and the face of influence. We can see that in the body of influence, the finer mesh is generated throughout the entire body. However, with the face of influence, the finer mesh is only present around the specified face. This allows for targeted mesh refinement, depending on whether the area of interest is an entire body or just a specific face. To incorporate curvature, import this geometry into Fluent Meshing. Use Insert Clipping Plane to view that only a simple body is inserted into Fluent Meshing. Change the option from No to Yes in response to, would you like to add local sizing? Change the size control type to Curvature. Set a local minimum size of 0.001. And for the curvature normal angle, use a value of 2 degrees, meaning the software will generate mesh elements every 2 degrees. For example, a full circle with 360 degrees and a setting of 2 degrees will result in 180 mesh elements. If set to 1 degree, the software will generate 360 mesh elements. In this part, we select the outlet for local sizing. In the Describe Geometry section, choose that the geometry consists of only fluid regions with no voids. Finally, in the Volume Mesh section, click on Generate Volume Mesh, and the software will start creating the mesh. To teach how to use proximity in Fluent Meshing, we've created this geometry. As you can see, there's a gap at the bottom of the geometry. In the Add Local Sizing section, change the option from No to Yes in response to the question, would you like to add local sizing? Select Proximity as the size control type. For the minimum size, I've used 0.01. And for the proximity condition, I've set it to 10. This means the software will generate 10 cells within each gap. We select the wall in this part and click on Add Local Sizing. Similar to the previous trainings, in Describe Geometry, choose that the geometry consists of only fluid regions with no voids. Finally, in the Volume Mesh section, click on Generate Volume Mesh, and the software will start generating the mesh. Once the software generates the mesh, zoom in on the gap. You'll notice that the software has created a finer mesh in that area, generating 10 mesh elements within each gap. This demonstrates how the proximity setting effectively refines the mesh to capture details in narrow spaces. To create local refinement regions, we begin with the geometry of a cube and subtract a smaller cube from it. After importing this geometry into the software, we don't need to add a local size immediately. Instead, right-click on Add Local Size, proceed to Insert Next Task, and then select Create Local Refinement Region. Although we can rename the local refinement region, we set the region type to box. We use the relative to geometry size method to determine the coordinates with a mesh size set to 0.03 meters and select Flow. In the software monitor, you can see the main refinement box outlined with a pink line. The box parameters display key details, such as the minimum and maximum values for the x, y, and z coordinates. If you adjust the box parameters, for example, setting the minimum from 0.1 to 1, you'll notice changes related to the length of the domain as the box separates from the regime. By setting it to 2, the region becomes twice the size of the domain. In this scenario, applying a finer mesh around the smaller cube is essential. Therefore, we set the x minimum to -0.5 and the x maximum to 0.5. The y minimum to 0 and the y maximum to -0.5. And the z minimum and z maximum both to -0.3, thus defining the refinement box parameters. Click on Generate Local Refinement Region. Then, navigate to Geometry Description to ensure the geometry consists only of fluid regions with no voids. Finally, go to Volume Mesh and click on Generate Volume Mesh. The software will begin creating the mesh based on these settings. It is evident that the software generates a finer mesh in the defined local refinement region. This is because the settings you've configured for the refinement region ensure that a denser mesh is applied to capture more detail in areas of interest, such as around the smaller cube in your geometry. This local refinement is crucial for achieving precise simulation results where more detail is required. In local refinement regimes, an alternative method for specifying coordinates is the direct specified coordinate approach. This method allows you to input the exact x, y, and z minimum and maximum values for your geometry. You simply set these coordinates according to your requirements. Once you've set the coordinates, proceed to describe geometry, ensuring that you define the geometry as consisting only of fluid regions. After this step, navigate to Volume Mesh Generation and click on Generate Volume Mesh. The software will then create the mesh using the exact specifications and refinement settings you've provided. This figure illustrates a mesh generated with local refinement regions using the box method. The visual highlights the software's capability to create a finer mesh in specified areas, enabling enhanced detail and accuracy in simulations. This approach targets crucial sections of the geometry, ensuring that complex features are captured with greater precision. This slide focuses on the offset surface method for creating local refinement regimes. In this approach, a mesh size of 0.005 is specified, and a small cube identified as wall 2 is selected for refinement. Within this regime, users can adjust the flow direction, whether originating from the X, Y, or Z axis. By clicking Flip, the flow direction can be reversed. The growth factor can also be manipulated. Increasing this number results in a larger mesh size beyond the specified boundary conditions. Once these settings are finalized, click Create Local Refinement Regimes. Proceed to Describe Geometry and ensure the geometry is defined as consisting only of fluid regions with no voids. Finally, move to Volume Mesh and click Generate Volume Mesh, prompting the software to begin creating the mesh based on these configurations. This geometry was created to teach the circle type of local refinement regime. We can see the inlet, which is circular, and the whole geometry resembles a cube. In the Fluent Meshing, when we insert this geometry, there's no need for additional local sizing. We create local refinement regimes using the circle type. For the method, we use a vector and length, setting the mesh size to 0.005. If we select the flow, the software will create a cylindrical refinement in the middle of the domain, but we need to create a regime at the inlet. Therefore, we choose the inlet, then offset the vector in the x component by setting it to 1. For the radius, we set it to 0.25, and for the radius 2, we use 0.252. The length can be adjusted. I use 1 meter, but 0.2 meters is sufficient for our needs. To demonstrate another method for positioning, we select two positions. The first position is at the center of the circle, and the second position is at the opposite side of the cylinder. For both positions, we can set the radius of the cylinder. After that, we click on Generate Local Refinement Regime. Next, we describe the geometry, ensuring that it consists only of fluid with no voids. Finally, we navigate to Volumes and generate the volume mesh. I hope this video is helpful for you. To benefit from Mr. CFD services, including simulation, consultation, and training, visit our website, www.mester-cfd.com. Contact us via info@signmester-cfd.com.